Okay guys, this is the third video of 3. I am having to re-record it. I don't know what happened. It didn't process last time. So I'm just going to redo this one. Alright, 26. Number 26 on your highlighted Verifying Trig Identities homework. Alright, secant of theta in terms of sine of theta. Okay, so we need to make a connection here, and once things can be put in terms of cosine and sine, you're guaranteed that you're going to be able to get somewhere with the Pythagorean identity. So I am going to convert this to 1 over cosine of theta. Okay, and I know that I have the right to square the top and square the bottom as long as I do it to both sides. Well, why am I doing that? Because I want to turn cosine squared into theta, because we can do the variation of the Pythagorean identity. So I am going to temporarily square this guy, and it's going to be 1 over cosine squared of theta. Well, I can then convert this to an equivalent statement of 1 over, and again, the variation is 1 minus sine squared of theta. Okay, so I have converted this secant into 1 over cosine. I legally was able to square the top and the bottom, and temporarily gave me 1 over cosine squared of theta, which I know is equivalent to 1 minus sine squared of theta. Well, now I want to take the square root of both sides, okay, plus and minus, and this is going to give me over here 1 over cosine theta again, so we're back to secant, and now I have plus or minus. Well, 1, the square root of 1 is 1, right? And then I have the square root of 1 minus sine squared of theta. Alright, so we have to rationalize the denominator. So it is not a conjugate situation because this is just a simple radical. And to rationalize radicals, we multiply the top and the bottom by the radical that we're trying to clear. We're trying to clear the radical 1 minus sine squared of theta and 1 minus sine squared of theta. Remember, our goal is to have sine running through our final expression. Well, I can convert this guy now, and I can convert him back to secant, right? And then we can say, okay, if I multiply this blue 1 times this rationalization factor here, then it's going to simply be the square root of 1 minus sine squared of theta over, and a radical times itself just releases the radicand, right? The radical sign goes away. Alright, so what we have done here is we have said, and oops, I forgot to bring my plus or minus down here. So, plus or minus the square root of 1 minus sine squared of theta over 1 minus sine squared of theta is the expression in terms of sine that represents secant. Alright, let's do another one. Let's go to 27. And this is the last one of this series of videos. This is video 3 of 3. Alright, 27. We're going to take cotangent of theta, given, and we're going to make an expression, and we're going to convert it using our identities where sine is the only thing that's running through it. Same situation as the last time. Alright, well, cotangent, I'm going to start and say, okay, I know that's cosine over sine. Remember, if you can get it in terms of sine and cosine, you're probably on the right track. Alright, I know that I can square this just like I did in my last one, because if I can get cosine squared and sine squared, I've got an easy in to the Pythagorean identities. Okay, so I'm going to take a look at this and say, well, that leaves me with cosine squared of theta temporarily over sine squared of theta. Well, I know that cosine squared of theta, if you look at the variation of Pythagorean, is 1 minus sine squared of theta. Okay, that gives me what I need there. And then sine squared of theta is already in terms of sine, so he's going to stay there. Alright, now I need to revert back and get rid of this, right? And I'm going to take the square root of both sides, so plus or minus. Okay, I'm not solving here. Remember, I'm just trying to convert or transform. So now, cosine of theta over sine of theta, which puts us back in cotangent mode, is equal to plus or minus the square root of 1 minus sine squared of theta over, well, if you take the square root of sine squared of theta, then you're just going to get sine of theta, right? Because you can take the square root of that. Okay, so the final cotangent, we go back here, has been absolutely transformed perfectly legitimately into the plus or minus the square root of 1 minus the sine squared of theta in our numerator over sine of theta. Alright, so again, focus on getting, you can square both sides, and if you can get something in terms of sine and cosine, that's great. Now there's one we did earlier that was secant and tangent, and we had to temporarily use that because there was no other way to get it there. But squaring the top and the bottom is perfectly legit, or even setting it equal to a variation of a Pythagorean identity. And you have 3 Pythagorean identities in the middle of that formula sheet that you have. Alright, I hope that was helpful.